Hello, my friends of Hatari Labs. Welcome to this webinar. In the webinar of today, what we are going to do is we are going to run a sensibility analysis of transient pumping test with MODFLOW-6, Flopy and SALib. Okay, this is this is a step, okay, that is based in another tutorial. Just to mention that there is a new tutorial right now that is how to import a leaf flow geological model into model muse with Python. This I have done it some hours ago, so I hope that you enjoyed it. And because it's not related not only to leapfrog but to any model that you have on BTK, you can transport that to model muse. Okay, and well, um, this is the second part of this other tutorial. Okay, so we have done, okay, there is this tutorial where we have developed a pumping test, okay, over aquifer, and now we are going to do, this is a transient pumping test, and we are going to do a sensibility analysis of that pumping test. Okay, so well, you have received on the description of the webinar, you have received this the zipped folder of this. Please place it under your documents, and then if you have it under your document, please type 1. 2. Okay, if you have it under your document, please type 2. Okay, great. So let's see. Okay, so let's Anaconda Prom, CD documents, CD webinar of sensibility analysis. But in order to ensure that we are working with the same, I'm going to oops, sorry. Hey, what went wrong here? Oh, I'm going to download what is on the I'm going to download the file that is this one. Mhm. Just to make sure that we are working with the same data. Okay. Okay. Downloaded. Control C, Control V. Okay. Okay. Now let's see. Anaconda Prom. CD documents, CD webinar. Okay, Jupyter Lab. Okay, so you have here the an executable because actually you have to run the model. Okay, then you have some images of the report. Then you have the model itself. Okay, that is pumping test. Here is where the scripts are, and on the text files there are some. Mm, well, there is the backup, okay, because the sensibility analysis can't last for long. I mean, it can last 3 or 4 hours because it has to rerun the model several times. So that is why here we have supposedly what you are going to have, and this is the folder where the working model will be. Okay, so everybody, let's go to script and let's start a new notebook that will be called part 1. Part 1. Great. If you are here with me, please type 2. 3. If you are here with me, please type 3. Okay. Who else? Anybody has problems? Okay, so let's work with our model. Let's say import OS from working tools, import para model, import pandas as PD. Okay, these are the required package. Mhm. Then we have to define some of the uh, we have to define some parameters of the model. Okay, the sim name is mfsim.nam. Okay, where is located? The working folder is in model pumping test. Okay, the exe name is equal to mf6 because we are in Windows. And we are going to store this on working model. Mhm. Okay, I have used for this a class, a Python class that is actually under working tools. What does it mean? What is a class? A class is a group of variables and functions, okay, that has a certain meaning, has a certain logic, okay. However, this is done in order to, because some of the steps are the same, some of the steps are repetitive. So if you want to do more code in with less lines, you create a class because this class can be applied not only for this case but for other cases. Okay, so that is why here we initialize, okay, mhm, an object from this class. And this is a comma. Okay, with this we initialize and then we load the simulation. Okay, and then we load the simulation. Parsing load simulation. Okay, and it will load all the package and all the simulation. So, okay. Uh, and the load simulation will also delete all the load simulation will delete whatever is on working model, okay? Uh, because actually the working model, okay, we are going to run the sensibility analysis, we are going to have several versions of the model. Okay, and these several versions of the model, for every step that we do, we need to we have to be sure that the folder where we are storing this iterative model is empty. Okay, if you have any questions, let me know, because don't be shy about this, because it's really important for us to ensure that you understand. I mean, this is not a live plan. It's, this is in any case, this is in any case a light topic, okay? So whether you are so intelligent, because I'm not, so you can do, okay? We changed the sim path because we don't want to, we don't want that the modified version is on the same folder, okay? And then we load the model, because in MODFLOW-6 you have the simulation and the model. There is only, in this case, there is only one simulation in the model, only one model in the simulation. So the ground water model is parsim, okay, load model. Actually, if you see, we are working with the Python class, and the name is actually appears here is pumping test. Okay, so, and the model also give you by default all the package that it has. So it has the this, the NPF, the initial condition, storage, general head, wells, output control, and observations. Okay, if you are here with me, please type 4. Okay, Miguel Ángel Bordallo has Miguel Ángel, this is my WhatsApp number. Could you send me a screen of what you have in order to provide you with support? Okay, who else? I mean, in order to, yeah, in order, I mean, you have, you, for this code, you need the working tools is here, okay, at the same level of your notebook. Okay, let's see what Miguel Ángel has. Okay, well, okay. Miguel Ángel, you're from Spain. Okay. My friend do not have PyVista. Yeah, because working tools needs PyVista. So you just have to do this. You just go to the terminal and just type pip install PyVista, and that's it. Mhm. Okay, and rerun again, and that's it. Okay, Miguel Ángel. Great. Okay, so we have, okay, so I don't know if you have experience with a pest, but in order to do the sensibility, you need to have some range. I mean, you have to vary your parameters over a certain range. And great. And in order to define the range, you need to know which which values do you have for the different parameters. And for that, I have done in the Python class some parsing. Okay, so it's a unique values npf k parsing unique values of. Okay, so we are going to have the values of the vertical horizontal conductivity and the vertical conductivity, and as well of storage parsing dot unique values of storage, and for the parameter sy and parsing dot unique values of storage for the parameter ss. Okay, great. So here we have the values of the k, y, the k, horizontal k, and the vertical k, as well the specific GL and specific storage. Okay, if you are here with me, please type 5. Mhm. Okay, now what we are going to do is we are going to create a function that will run the model, but for a specific set of parameters, and the set of parameters is k of layer 2, k of layer 3, k of layer 4, the specific storage, and the anisotropy. Okay, so those are the parameters. Okay, if you have, for example, if you want to insert conductance of the boundary condition, okay, you have to insert one parameter more, okay, and then you can insert all parameters that it has. Raw model for params k lay to original, because we have to provide the original value k lay 2, and as well the same thing for k lay 3 original, k lay 3, k lay 4 original, k lay 4, the SS, and the anisotropy. Okay, great. So we have to define as well the same sim name mfsim. Okay, so because we are lazy, and this is actually the same, so we just copy that. Okay, so sim ws xname working model. Okay, then we define the parsim as well, because we open the model. Okay, then we load the simulation. Then we change the sim path. Then we extract the groundwater. Okay, we do everything in this function, because okay, and as well the npf, no, here the npf is equal to gwf dot get package npf karray is equal to np dot copy the npf dot k dot array. Okay, so why we do a copy here? Because in Python there is inherence, also there is okay, so a variable can be attached to the package itself, okay, and then if you do an assignment on the variables means that you are assigning on, or you maybe you can do ¿cómo se dice? Cross reference. Okay, so you are trying to change something. Okay, this is a problem, so that is why we create a copy, so we ensure that this variable is not the, we ensure that this variable is not the original one, so it's the value, but it has no history. Okay, so and for that, k array of k array, when k array is equal to k of layer 2 original. Okay, this is the value of k layer 2. We know already which is the value of k of layer 2. Okay, we apply this our designed value, and as well we do that for k3 and k4. Okay, once we have modified this array, we just type npf, we assign npf dot k33 is equal to k array divided by anisotropy. Okay, great. Yeah. Mhm. The storage is equal to gwf get package storage is sarray is equal to np.copy of esto.ss array. Okay, ss array is equal to, okay, okay, we open the link. And then, but we, based on the shape of this link, we create a new array with the new ss value. Okay, okay, so we apply the new value to the specific storage. So we have k of layer 2, k of layer 3, k of layer 4. If you want to know which are the layers, so you go here, you go to image, and then you go here, and then you will find that the pumping test is pumping from the layer 3. Okay, so you have layer 1, 2, and 3, and the piezometers are located in layer 4 and in layer 2. Okay, so that is why, and we don't think that the upper layer will be sensible in any case, so that's why we only work with k of layer 1, 2, 3, and 4, and then isotropy and the specific storage, because everything is confined. Okay, and well, yeah, I mean the layer 2 and 2, 3, and 4 are confined. The layer 1 is not confined, but we, on our conceptual model, we don't think that this will have a great impact. Okay, if you are here with me, please type 6. Mhm. Great, 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 great. Who else? No one else? No one has problem as well? No one? Yeah, no one. Okay, so but still we have to parse sim dot write simulation silent is equal to true, and say parse sim run simulation silent is equal to true, and then say ops is equal to gwf dot get package. Oh yes, ops file is equal to list of ops continuous continuous dot data dot keys 0 psodf is equal to pd dot read csv os. Okay, so we open the package, we open as well the file, we transform the file into a pandas data frame. Okay, and we are working, okay, there are two, okay, there are two piezometers and as well as the well, but we are going to work with just one piezometer. Okay, I mean, for this, you have to work with just one piezometer, but you can do you can do the sensibility for the readings, for example, in the recovery you can do the readings on the recovery of the pumping test, on the pump itself, okay? Okay, so this is the function, and then we try this function for a certain data set, okay, for a certain values, because for certain values, okay. So if you are here with me, please type 7. If you are here with me, please type 7. Mhm. Okay, just to mention that we have a coming diploma in Python with Flopy. The coming diploma is from March to July, and this is the only diploma that we are going to give it live. So if you will want to learn Flopy from the beginning with apply examples, and then you are going to have a discussion on several cases, and then, because mostly about the methodology that we are going to cover, because you have to understand Flopy in the way of how it's coded. Okay, so we are going to explore that. Okay, I strongly recommend to take this. I strongly recommend to take this diploma. Okay, so the link of the diploma is on the chat, and hope to see you there. Great. So let's see. Piezo data is equal to run model for params of, and then since I'm really lazy, I copy this. Okay, I copy this and say clock. So the original value of the key of the layer 2 is 1, 1 to e to the minus 5, 1, 2 to e to the minus 5. The value that we are going to take is 2, 10 to the minus 5. 1 point the e to the minus 6, and the value that we are going to test is 2 point e to the minus 6, and the k4 is 3 even to e to the minus, and the value that we are going to try is the specific storage that we are going to try here is 0.01, and the anisotropy is equal to 12. Okay, so let's check. 1, 2, 1, 2, 3, 4. Okay, so let's run this, and it will run the simulation. It's running, the simulation is run, and it will return the piezo array. So it will return all the heads for the piezometer, for this piezometer, okay, over all the times of the model. Okay, great. If you are here with me, please type 8. Okay, it's running. Okay, it has run. If it has run for you, please type 8. If it has run for you, please type 8. Great, Victor. Who else? Who else? Okay, well, it has run, so let's explore what it comes with the run. Ah, I have a problem. I have a problem. Ops files. Ah, it's ops file. Sorry, it didn't has run for me. Yeah. Sorry, I mean, it has run, but the function didn't finish. So my error was here in ops file. Mhm. Okay, so let's have a look. Okay, and if we look for piezo data, and these are the values every time, every stress period, okay, we have these values, okay, on this piezometer. Great. So, and it has a length of 29. Okay, so now we are going to perform the sensibility analysis. For that, we see import Um, so for this, we are going to solve samples. Okay, yeah. So import salib.sample.sobol a sobol sample from salib.analyze import sobol. Okay, so we define a problem. Problem is equal to a dictionary where the number of variables, number of vars is equal to 5 with the names are equal to k of layer 2, comma, oops, sorry, control C, k of layer 3 and k of layer 4 is S and anisotropy, mhm, and the bounds is equal to, okay, here is, okay, the bound is np log. Okay, why we are going to use the log of the function on the sensibility analysis? Why? Because there's an explanation here why we use the log of the function. Mm, for the sampling, because actually uh, because this algorithm actually will take, for example, layer 2 that vary from 1 10 to the minus 5, 1 10 to the minus 4, and will look for intermediate values. When there is a log, it can use a, can say, yeah, equal distance. So, and this equal distance will tend to values that are on the higher end. But when you use log, you are going to separate better the distance. It has an explanation like this. I leave you the discussion. It's too long to np log. Okay, so the k of layer 2 will vary from 110 to the minus 6 to 110 to the minus 4. Okay, this is for the first variable. Okay, and then we copy that 5 times. Okay, and the other is one from 110 to the minus 7 to 110 to the minus 5, and the other is from 310 to the minus 6 to 310 to the minus 3. And this is for the specific storage. This goes from 0.0001 to 0.001. Okay, and this is the log in Python. In Python, this is the logarithm is from the, not from base 10, it's from base exponential. Okay, I don't know if you understand this. Okay, it's not log of 10, it's log of e, 1 and 100. Mhm. Okay, great. So, and then we sample log of param values is equal to sobol sample. Okay, we are going to sample problem, and the second argument is a number that says how many parameters Okay, in how many, well, it's related to how many, in how many parts you are going to define each interval. Okay, it's related to that. So if we type 16, and then if we, I mean, if we can get the log param values is a list, okay, and then what you see here is the logarithm of these values, okay, that range. For example, the k of lay 2 will range in these values, the other will range in these values, and the other will range in these values, okay, um, and how many values do we have, or we will do this. So it's a print log values shape. Okay, so we are going to have 192 combinations. Okay, if you are here with me, please type 9. Great. So, okay, so we create a head array, okay, head array, okay, because we want to store all these values, zeros, of log param values dot shape 0, okay, and then shape. Okay, so we have the, okay, for each combination we store, okay, so we how is it, for all the combinations we store five, the all the values of the heads in the different stress periods, okay, so we are going to have an array of 192 times 29, because for each combination we have 29 head values in the piezometer. Okay, so what we are going to do is we are going to look for each combination for index param in enumerate of log param values, great. Okay, we can print the index. Okay, this is a break line because I want that the index has one empty line before and one empty line under. Uh, Print str the param of class. Okay, and then we apply the params, and then we run our function, this one. Okay, but this function will, instead of a piezo data, will be stored in the head array. Okay, and the, well, this is the original one, but this will be MPE elevated to the param 0. Okay, and this will be elevated to param 1. This will be elevated to the param 2. This will be elevated to the param 3. And this will be elevated to param 4. Okay, so we are running for this combination and it actually is running. I'm going to stop that. Why I'm going to stop that? Because it will run the model 192 times. Okay, and this can take, you are going to run it and maybe it will take 6 hours. Okay, so that's why we are not interested in doing this. Okay, but we are going to, okay, okay, the head array we are going to, we are going to open. Okay, well, later on, okay, once you have your head array, save, so you can save your head array txt once you have it generated. Okay, head array.mpy head array. Okay, now your head array is only of zeros. Okay, but we are going to load a simulation that was already done. So say working array is equal to np load of txt head array backup, the one that is on the backup. Okay. Okay, so if we have all of these values, and then we are going to use this for our sensibility analysis. Sobol analyze of problem working array okay print to console is equal to true. Okay, so this is the, okay, this is the analysis of the problem for the first combination. 192 rows. No, for the first time. This is the analysis of the sensibility for the first time. Okay, so this what do we see? That is more sensible to K of layer 3. Okay, and for this time, and not much to layer 4 and to the anisotropy as well. For this time. Okay, so because this is the static, the steady state for the transient, yeah, we see that it's more sensible to K of layer 4 than to K of layer 3 and 2. Okay, because this one is the first of the static one. But let's see, okay, let's have a look because the sensibility depends with time. Okay, so let's have a look on this graphic because the graphic is amazing. Okay, but if you are here with me, please type 1. Okay, so now what we are going to do is we are going to do a sensibility array. Okay, sense array is equal to np zeros of piezo data shape of 0 problem of numbers for piezo in range of piezo data shape 0 Si is equal to Sobol analyze problem working array. And then we add sense array piezo. Okay, well, actually it's piezo data. It's not for piezo, it's not piezo, it's time in this case. Well, where the code is come for piezo, but it's the time because it will be a sensibility for every time. Problema. Okay, so here we have a matrix that for every time we have the sensibility to the 5 parameters. Okay, if you are here with me, please type 2. Okay, so now we have, okay, so everything is a time, but we don't have the times. Well, we have the time, so gbdf dot model time dot im, but the time is in seconds. So actually, this is not such a great indicator. So we are going to do a list of the time, but in days. Time list is equal to. Okay, so this is time list, and this is in days, and this is as a text. Okay, time is 5. Okay, these are the 5 time values. Okay, great, because there were 3 days of pumping and 3 days of recovery. If you are here with me, please type 3. So I say np.random.seed 0 sns dot set SNS dark palette pale green as CMap true. Okay, because we are going to use Seaborn. Okay, if okay, and well, we can this is pumping day, pumping time day parameter. Okay, great. So if you are here with me, please type 3. If you are here with me, please type 3. Okay, so let's explore this graph, and this graph is amazing. Okay, what it says, this graph? Okay, this is for the steady state. Okay, the state on the steady conditions, the model is actually really sensible to decay of layer 3. Okay, but when it starts pumping, is sensible at the beginning to a specific storage. Okay, then is sensible to decay of layer 4, and when it stops pumping, okay, on the recovery is sensible to the anisotropy, okay, and then is sensible to the specific storage and to K of layer 3. This is an X-ray of the sensibility, and this will help you a lot in understanding what is going on with your model. Okay, especially because the sensibilities, and especially if you want to reach a degree of accuracy, is really difficult. Okay, so this will help you to define what is going on and how to play around with the variables, and uh, that will be the end of today's webinar. Do you have a question? Do you have a question? Okay, I will stop the recording, and if you wait